Hello everyone, today we're going to talk about list interface. Firstly, I want to show you documentation. In documentation we see that list interface extends collection interface, and which means that list interface inherits methods from collection interface. And now and also there are some additional methods in list interface, and now I want to give you an example to show one of them. Let's look at this code. In this code we see that first I create an array list and add to this list some elements. When I run this code, the output is 1, 2, 4, 7, 6 and 15. And suppose that I want to add one more additional element to this list, for example 3. If I run this code, 3 will be seen at the end of this list. Yeah. But what should I do if I want to put the 3 in between 2 and 4? I need to specify the index number, for example 2. But I cannot do like that because let's go to the documentation of collection interface. There isn't an add method with 2 parameters. So but instead of collection we can write list. So it is not there isn't error, so because in list interface we have one more addition add method with 2 parameters, and so we can specify an index number. And now I want to show you let's run this code. If we run this code, 3 should be there. Yes, 1, 2, 3, 4, 7, 6 and 15. And now I want to show you one more example. Let's go back to the collection. And suppose that you want to sort these elements by using collection sort and array. You cannot do like that, because if you go to the error, we see that the method only takes list. We see that the required type is list, and the method only takes list. It doesn't support collection. So there is a problem with collection interface. You cannot add values in between. That means it doesn't work with indexes, and that's why we cannot even sort the items, because we don't have indexes. That's why we need to use lists. There are 2 concrete classes of list interface: array list and linked list. Array list can be used to store an unlimited number of objects. In array list you can add more values as per your requirements. You can expand the size of array list, you can shrink it, you can do all this stuff with array list. The same thing is possible with linked list. You can do the same thing. You can add an elements, or you can remove elements, and the differences is their implementation. Array list implemented with the help of a concept of dynamic array, and linked list by the concept of double linked list. If you store the elements in array list, it means you store the elements in array with initial length 10. If there are elements exceeding 10, it automatically increases its size. So suppose that in array list you have such elements 5, 7 and 8. So what happens when you add elements in between? So let's say I want to add element after 5. If I add element which is 6 in code, I should use method add 1, 6, and the other elements will take the next index numbers of numbers. It means 7 will take the index 7 will take the index 2, 8 will take the index 3, and if you add an element in between, it will update the next element. We have to change the index of every element, so it is time consuming. It will take some time, and there is one more problem with removing an element. For example, let's say if you remove 6, all the elements after 6 will go up. What about linked list? Since linked list follows a concept of double linked list, every element you add, let's say you add an element which is 5, so this is a starting element here. As soon as you add the element, it will make a node of it. In this node, you will have two things. One will be the next node, and second will be the previous node. And then you add 7. It also have two things. So 5 will mention that this 7 is next. If you have another element 8, again there will be two things. For 7, previous node is 5 and next node is 8. And now if you add an element 6 in between, for example after 5, it also will have two things. As soon as you add new element, you just have to change something. That something is, instead of this next element, which refers to 7 from 5, you have to refer to 6. You have to refer the next element to the 7. Now the previous element for 6 is 5 and the next element is 7. We are just changing two objects. This will not affect in the number of nodes you have after that, and it will not affect the numbers before that. So it is very good when you want to add elements in between, because linked list follows the concept of double linked list. In this situation, who wins? Of course, linked list, because when you add elements in between, linked list works faster. But if you want to search the element, you have to use indexes. In array list, you can specify the index number, so it is very easy to search. But in linked list, it is difficult to search. So in case of searching, array list becomes faster and then linked list. And thank you for your attention. Goodbye.